Hello guys, welcome back to General Channel. Today I'm going to discuss about expression for pressure of a gas. So this topic belongs to class 11 physics. So this derivation is very important for class 11. It's so easy also. So there are two ways of doing this derivation. One is short one but hard. One is long one, literally wrong, but very easy to do. So now in this to understand this derivation, we'll be starting with a cubical container. So take a cubical container. You will be having air in it. Yes, right? Air will be present in that. So consider a particular molecule, say X, Z or whatever it is. Take the velocity of that particular particle in all direction as v1 along x, v1 along y, u1 along x and w1 along axis. So this is what you're assuming here, and A and B are the two opposite faces of cubical container, right? Clear? So now we are having N as number of molecules per unit volume and N, capital N, as number of total molecules present in cubical container, and C as the velocity, sum of the velocity along three direction x, y, z. So this particular equation is written in this form, right? Is it clear, right? So as I said I have wrote the N is nothing but number of molecules per unit volume. Capital N is nothing but total number of molecules. C is nothing but speed of one molecule at any instant. And M is mass of each molecule, right? So length is the L is the length of cubical container. So now what we are discussing is we have assumed the particular molecule X over here, right? Now when X bounces onto A, it rebounces back, right? That's what will happen. When X goes and strikes face A, it will definitely rebound with velocity. Now as the velocity is on negative direction, the sign will be negative. That's what is going on here. So this is the molecule X. It will go and strike the face A with velocity u1. It has to rebound with the same velocity but in negative direction, that is u minus 1. This concept we are using. So what is the change in momentum of this particular particle? We have to find that. So change in momentum will be final momentum minus initial momentum. What is the final momentum of the particle? Yes, definitely this one. Okay, we don't have to put delta because mass remains constant v, but the final momentum is of negative, right? Because velocity has the negative sign. So the answer of change in momentum will be this. 2mu. Now that you have got the change in momentum of the particle, now let us find out time taken by the particle. Time taken will be definitely distance covered by speed. So what is the distance covered by the particle? Yes, here. The particle bounced and again rebounced, right? That is 2d. This is the distance d. It has covered the same distance 2 times. Therefore, distance covered is 2d. So 2d, and speed that is u1. So time you got and even change in momentum you got. So you can easily find out rate of change of momentum. That's what you actually need. Momentum. So how to find the rate of change of momentum? Delta p by d t. Okay. So rate of change of momentum is equal to change in momentum divided by time. So what is change in momentum? Final momentum minus initial momentum. We have done that before and we got this answer. Now change in time. What is time? Yeah, 2d divided by u1. And this is the answer we got. Once we simplify this, we'll be getting another answer which will be equal to total force. Now let me explain you how rate of change of momentum will be equal to total force. See guys, force is equal to momentum divided by time. What is momentum? P. What is time? T. So momentum can be written as mv. T can be written as T. So m into V by T equals ma. So ma equals force. You know that by that particular equation you were able to derive this whole thing, right? So momentum by time equals force. Momentum by time equals rate of change of momentum. Did you get it? So these two equations we are equating. Yes. So force equals this. So force equals this. So let me rub everything now. So we have brought this u1 into numerator. Now what will happen? 2 will get cancelled. u1 u square it will come. So this is the final answer we get. So this is nothing but rate of change of momentum, which can also be written as force. I said how just now. Forgot to write L or D in denominator, sorry. So guys, what is our aim? Our aim is actually to find pressure of the gas, right? So we have started by that. We have started in order to find the pressure of gas. So how is force related with pressure? Exactly. Pressure equals force by area. Now force formula you know. A value you know. So this is what will happen. Force you have substituted A, and A can be written as L square. L square, L into L, that is length into length. Area of the whole cube is nothing but length of the cubical cube into length, right? That's what the formula of area, right? So we have got the final answer as this. But this whole equation describes only about a single particle. But if you want the equation to be described of all the particles, what if you want to include all the molecules in the cubical box into this equation? Then we'll get this particular equation. There are n molecules in the cubical container and they have the particular velocities, right? We have taken the velocity only along x-axis and not along any axis. If you want to take along y and z, you have to consider px equals py equals pz equals p. That's what we are gonna do after this. And as mass and length is equal, length of cubical container of each molecule is equal, right? So we took these both as common, and the velocity itself we put it aside. So I wrote it for you actually. Px this one, Py this one, and Pz this one. So we are assuming Px equals Py equals Pz equals P. So here Px plus Pz plus Py equals 3P, and this is the formula we got. Once we substitute in this equation and we simplify that, we'll be getting the required result. And if you still want me to upload, I'll upload the next part in next video. Just please comment in my comment section. And guys, don't forget to subscribe. It really helps, really supports me a lot. And please don't forget to like, comment and share this video. Thank you so much for watching. Please stay tuned. Bye bye.